Imagine looking in the mirror and seeing not just yourself, but your future. That's what Venus is for Earth. A planetary reflection warped by catastrophe. It's nearly the same size, born from the same cosmic neighborhood, and built from the same materials. And yet, it's a place so extreme that lead melts in its shadow. The air could crush a submarine, and rain never touches the ground because it's made of acid that evaporates before landing. Welcome to Venus, Earth's evil twin. And trust me, this isn't just about one hellish world. Venus might just hold the key to understanding how fragile life is, how rare Earth might be, and what could happen if things go wrong. If that sounds like a trip worth taking, give this video a like, subscribe to Cosmo Pulse, and buckle up, because we're about to visit the most terrifying mirror in the solar system. Let's start with the paradox. Venus is often called Earth's twin. Why? Because in many ways it's eerily similar. It's almost the same diameter, just 650 kilometers smaller. It has about 81% of Earth's mass. Its gravity is nearly the same, and it orbits in the so-called Goldilocks zone, the region where liquid water could exist. Both planets likely formed around 4.5 billion years ago in the same part of the solar system. They're both rocky, with iron cores and basalt crusts. From space, this looked like a double act, two worlds born equal, but then something went wrong. While Earth developed oceans, forests and Netflix, Venus descended into madness. Today it's hotter than Mercury. Despite being farther from the Sun, its surface simmers at around 465 degrees Celsius, enough to melt lead. And the air? It's 96% carbon dioxide, 92 times denser than Earth's atmosphere, and heavy with sulfuric acid clouds that swirl like a planetary fever dream. It's like looking at Earth through a funhouse mirror, one that shows what happens when a planet spirals out of balance. Standing on Venus would be like stepping into a pressure cooker inside a nuclear reactor. The air is so thick it would crush you in seconds. The heat? Instantly fatal. And just when you think you've adjusted to that, the sky starts raining, not water, but sulfuric acid. And it never hits the ground. It vaporizes mid-fall. Why is it like this? Blame the runaway greenhouse effect. On Earth, CO2 gets absorbed by oceans and locked into rocks. But Venus didn't have oceans. Instead, any early water vaporized, adding more greenhouse gases to the atmosphere, which trapped more heat, vaporized more water, and so on. A positive feedback loop that boiled the planet alive. Its skies are in constant chaos. The entire atmosphere rotates around the planet in just 4 days, even though the planet itself takes 243 days to rotate once. And it spins backwards. This phenomenon, called superrotation, creates winds that whip around at 360 kilometers per hour. Imagine Earth's jet stream on Monster energy drinks. Deep in the clouds, Hadley cells, giant convection currents, swirl heat and gas from equator to poles, while thermal tides, planet-wide waves caused by solar heating, reinforce the chaos. Venus isn't just hot, it's alive with turbulence. A real-time physics experiment wearing a sulfuric cloak. If you're enjoying this twisted tale of planetary horror, hit that like button. It tells the algorithm that more people should know just how weird our cosmic neighborhood really is. Now let's touch down, if you dare, on the surface. Venus's ground isn't still, it's volcanic. And I don't mean a few scattered volcanoes, I mean tens of thousands of them. About 90% of Venus is covered in basalt from past eruptions. It's a world resurfaced by lava, again and again. Some features are wild. Massive pancake domes up to 15 kilometers wide, formed by slow, sticky eruptions under crushing pressure. Others are so bizarre, they've been named after insects, like arachnoids and tick-like domes. There's no evidence of plate tectonics like on Earth. Instead, Venus's crust seems to lock up for hundreds of millions of years. Heat builds underneath, and then, boom, the whole surface may melt and reset in a planet-wide resurfacing event. Magellan radar data shows very few impact craters, and the ones we do see look fresh. That tells us the surface is geologically young, somewhere between 250 to 800 million years old. In cosmic terms, that's recent. It's like the entire planet hit the reset button in one giant volcanic purge. Even now, there's evidence Venus isn't entirely dormant. Some lava flows might be just a few decades old. The Venus Express mission found swings in sulfur dioxide levels, a sign of recent eruptions, and hotspots beneath the crust hint at active mantle plumes still trying to claw their way to the surface. Venus might not just be a cautionary tale, it might be a living nightmare. For most of history, Venus was just a dazzling light in our sky, the morning star or evening star. The ancient Greeks thought it was two different stars. The Maya built temples aligned to it. But what lay beneath those golden clouds? We had no idea until we dared to go look. The first to knock on Venus's sulfur-stained door was the Soviet Union. Their Venera program was the stuff of sci-fi grit. Venera 4 was the first to taste the atmosphere in 1967, and it choked on carbon dioxide before being crushed 25 kilometers up. Then came Venera 7 in 1970, the first human-made object to land on another planet and transmit data back. It lasted 23 minutes of silent-breaking courage. It confirmed 480 degrees Celsius on the surface, 90 times Earth's pressure, not just inhospitable, apocalyptic. Venera 9 and 10 beamed back the first images from the surface, a cracked, barren wasteland lit strangely by diffused sunlight, as bright as an overcast day on Earth, even under clouds of acid. Venera 13 pushed further, not just images but soil chemistry, light spectrum, even sound recordings. These were engineering triumphs. The landers were built to withstand forces that would destroy most submarines. It was like sending a robot into a furnace wearing a raincoat made of lava rock. Then came NASA's big play, Magellan in 1989. Unlike the Venera probes, it didn't land. It orbited, but what it did from up there was nothing short of revolutionary. Magellan used radar to see through Venus's clouds, mapping 98% of the surface with detail better than what we had for Earth at the time. It revealed the volcanic plains, pancake domes, and those wild arachnoid structures. It showed a young surface, few impact craters, and virtually no erosion. Venus was dry, dead, and lava-slicked. And yet, it wasn't the end. In 2005, ESA's Venus Express arrived. This orbiter was a Swiss Army knife of science. It made the first full-temperature map of the southern hemisphere, found a gigantic double vortex at the South Pole, and detected lightning more frequent than Earth's. Venus wasn't just weird, it was dynamic. One of its biggest finds, enormous fluctuations in sulfur dioxide. A sign that volcanoes might still be blowing their tops today. It also found an ozone layer, a mysterious cold patch possibly cold enough for CO2 to freeze, and confirmed that water, what little remains, is still leaking into space. Fast forward to 2015, Japan's Akatsuki. A mission that almost didn't make it. Its main engine failed, leaving it stranded. But 5 years later, engineers pulled off a miracle, slipping it into orbit using only its thrusters. Akatsuki focused on the atmosphere, and what it saw. Super rotation in action, equatorial jet streams, a massive bow-shaped cloud stretching 10,000 kilometers across, and cloud flows on the night side moving pole to equator, like ghost rivers in a world of acid. Venus isn't dead. It's just shrouded, constantly hiding, constantly moving. If you're still watching, don't forget to hit subscribe, because here on Cosmopulse we go beyond the headlines, digging into the deep science that other channels skim past. And trust me, Venus is just getting started. After decades of Mars hogging the spotlight, space agencies are turning their eyes back to the twin that turned evil. NASA's Veritas, launching approximately 2031, will map Venus's surface in high definition using radar, hunt for signs of current volcanic activity, and peer at mineral compositions to decode its hidden past. It's like giving Venus an MRI scan. Then there's ESA's Envision. Same launch window, different focus. It'll probe from core to clouds. With instruments from NASA and ESA combined, it will search for heat from active volcanoes, study atmospheric layers, and even sound out subsurface structures. India joins the party too, with Shukrayan 1 planned for 2028. Their Venus orbiter will carry ground-penetrating radar and high-res spectrometers. The goal? Detect past or present signs of volcanic activity and better understand how sunlight interacts with the planet's choking atmosphere. Why the sudden revival? Simple. We've realized Venus is the planet we need to understand, not just for its own mysteries, but for what it teaches us about planetary habitability, about Earth, about life, and about how thin the line is between a paradise and a furnace. For decades, scientists dreamed that Venus once looked more like Earth, with liquid oceans, gentle rains, and maybe even microbial life. After all, it's the same size, the same mass, and sits in the habitable zone. Why not? Some models suggested Venus could have had oceans up to 500 meters deep, and maybe life, which, when things went south, retreated into the clouds. That's what made the recent detection of phosphine in its upper atmosphere so exciting. But now, that dream is cracking. A 2024 study from the University of Cambridge may have ended the ancient ocean debate. It analysed volcanic gas chemistry and concluded that Venus's interior has likely been dry for most of its existence. The volcanic plumes contain almost no water. If true, that means Venus wasn't a paradise that turned hellish, it was born that way. A scorched child of the sun, never given a chance to cool down. It challenges everything we thought about habitability and forces us to consider a harsher truth. Not all Earth-like planets are potential Earths. Even worse, it implies that oxygen in an atmosphere doesn't always mean life. Because if Venus ever had lots of water vapor, photodissociation would have produced oxygen, even without life. Suddenly, everything we thought we knew about exoplanets gets murkier. Here's something weird. A day on Venus is longer than its year. While it takes 225 Earth days to orbit the Sun, it spins so slowly that one full rotation takes 243 days. And it spins backwards. On Venus, the Sun rises in the west and sets in the east, if it ever broke through the cloud cover at all. Why? One theory is that Venus was struck by a massive object early in its history, a collision so powerful it reversed the planet's spin. We've seen this before. Earth's moon may have formed from such an impact, and Uranus rolls on its side due to a similar event. If Venus was spun backward and then tidally locked by the Sun's pull, its current bizarre rhythm might be the final result. But this retrograde spin might be more than just a curiosity. It might explain why Venus lacks something Earth has and desperately needs: a global magnetic field. See, magnetic fields are born from molten cores rotating fast, creating dynamos. Earth has that. Venus, not so much. No spinning core, no shield. That leaves its upper atmosphere wide open to solar wind, which might have stripped away water molecules over billions of years, leaving behind a bone-dry wasteland. Without a fast-spinning interior, and without plate tectonics to regulate its carbon, Venus has been stuck in a slow-cooking disaster for hundreds of millions of years. And that raises the question: despite all the data we've collected, Venus remains a planetary enigma, and there are still major blanks on the whiteboard. We don't know if Venus quakes. Its surface is so hostile that no seismometer has ever survived long enough to measure a tremor. That means we're in the dark about its tectonic activity, how the interior behaves, and whether it rumbles like Earth. We don't know what's deep inside. Is its core molten, solid, magnetic? We've only modeled it indirectly. Without seismic readings, it's like diagnosing a patient without an X-ray. We don't fully understand the lower atmosphere. What chemical reactions are taking place beneath the cloud decks? How deep do the super-rotating winds go? Are there stable layers, or is it all chaotic turbulence? We're still debating its water story. Was Venus born dry, or did it lose oceans? And if it had water, where did the oxygen go after the hydrogen escaped? These questions cut to the heart of planetary climate systems. And most of all, we don't know if Venus is still geologically alive. The signs are there: sulfur dioxide swings, surface hotspots, radar differences in lava flows. But we need higher resolution data and longer-term monitoring to be sure. That's what the upcoming missions aim to answer. Veritas, Envision, and Shukran-1 will bring radar eyes, infrared spectrometers, subsurface sounders, even atmospheric probes, maybe one day even balloons. Venus is a veiled world, and we're only just starting to lift the curtain. You might be wondering, why care? Venus is hostile, uninhabitable, toxic, and, let's be honest, not somewhere we're ever going to terraform, but Venus matters, because it's the best cautionary tale in the solar system. If Earth and Venus started out so similar, and one became a cradle for life while the other became a pressure cooker from hell, then habitability isn't guaranteed, it's conditional, it's fragile. Venus shows us what happens when a planet crosses a line, when carbon builds up, when water vanishes, when feedback loops turn a gentle warmth into relentless fire. It makes climate change real, not just in graphs or projections, but in planetary form. This is what a runaway greenhouse effect looks like. This is what happens when a planet loses its balance, but it's not just about Earth. Venus is now the control variable in our search for life beyond the solar system. When we spot rocky exoplanets in the habitable zone, same size as Earth, similar distance from their star, we often get excited. But how many of those Earths are actually Venuses in disguise? Venus teaches us not to take oxygen at face value, not to assume that clouds mean water, not to mistake planetary similarity for planetary safety. It anchors our understanding. It's the dark mirror we hold up to every new world we find. Venus doesn't just exist in labs and data charts. It lives in metaphor. It's science's favourite cautionary tale. A planet that serves as both a curiosity and a warning. It's been called a hell world, a sulfurous inferno, Earth's evil twin. These labels aren't just clickbait. They're poetic truths. In documentaries, in scientific journals, in press releases, Venus is portrayed as the mirror of what happens when climate goes unchecked. Its clouds are made of acid, its ground melts metal, its air would flatten you, and yet it reflects the same sun. It was born in the same place. It's a cosmic what if. Even the phrase evil twin taps into something deeper, a shared origin, a split fate. In storytelling, the twin is never just a villain. They're a version of you that could have been. A life that took one wrong turn. Venus isn't just another planet, it's Earth's shadow. After decades of Mars obsession, something's changing. We're entering what scientists are calling a decade of Venus. Not just one mission, but three. NASA's Veritas, ESA's Envision, India's Chandrayaan-1. All aimed at one burning question. How did Venus go so wrong? Why the sudden interest? Because Venus might hold answers we've overlooked for too long. Not just about its own past, but about Earth's future, and about the razor-thin conditions that make a world livable. We're realizing that comparing Earth only to Mars is like studying a success story and a corpse. Venus, on the other hand, is a living paradox. The nearly made it, the planet that should have worked but didn't. It might tell us why Earth is still habitable, and how quickly that could change. Venus is a story. A violent, cautionary, fascinating story. It began like ours, but diverged into nightmare. It teaches us that the line between paradise and inferno isn't as thick as we'd like to think. That habitability is more than orbit and temperature. Its feedback loops, carbon balance, internal dynamics, and pure luck. It's a reminder that the cosmos doesn't do second chances, and that Earth's current stability isn't a guarantee. It's a moment. But here's the deeper twist. Venus also teaches us how to look at other worlds. As we scan the galaxy for Earth-like exoplanets, Venus reminds us that similarity doesn't equal safety, that oxygen isn't always life, that clouds might hide death, that the universe is full of Earths and full of Venuses. And so, the evil twin isn't just a catchy label, it's a narrative we need, one that keeps us curious, keeps us cautious, and keeps us humble. If you've made it this far, you're officially part of the Cosmo Pulse crew. Hit that subscribe button and give this video a like if Venus blew your mind. We post 3 long-form deep dives a week. And if you look up at 21:30 tonight, you might even see the morning star burning bright in the twilight. That's not just a planet, that's a warning and a wonder.